morning, everybody. I'm Chuck Boland from Zebra Technologies. We're going to talk about security. And joining me is Andy Smolak from Google, so he can help with some of the aspects from a Google perspective. Because obviously, looking at security, we've got to look at it all aspects, what Android provides natively and what Zebra's on top of that. So, Joe mentioned security during the keynote yesterday. Obviously, probably pretty full room. Curious, does everybody think, security is an important topic for an enterprise? So, really, what I get a lot of questions about security is, and the concern is, is Android secure? Years ago, Windows Mobile CE, 15, 20-year-old operating system really wasn't a thought. There weren't really too many hackers going after it. So we get a lot of questions and a lot of concerns from enterprise customers. Is Android secure? So really today we want to walk you through all the security measures that Android has put in, that Zebra's put on top of that, and give you confidence on how to talk about security and ensure you that the system is secure. When we think about security, obviously everybody goes to the recent headlines. Right? There's a lot of what we call the new terms we call in the U.S. these days, fake news. So there's a lot of headlines to talk about exploits and vulnerabilities, and it kind of sensationalizes a lot. A recent one that people have probably the ransomware attack or the WannaCry attack, right? Which affected a lot of computers. The truth of that is, Microsoft, to be fair to them, had actually already had a patch for that, several months earlier, but a lot of people hadn't actually implemented that patch. So, a lot of things, a lot of potential vulnerabilities here. We'll talk a little bit more about the reality of some of these a little bit later, and I don't want to minimize it. Right? I think everybody needs to be diligent about security, and we're certainly very diligent about security, as well as Google, but it's also trying to understand what the realities are there. When I look at security at our enterprise customers, I think of three main areas that people are concerned about security. First is leaking of sensitive data. So whether that's Wi-Fi passwords, which are particularly sensitive in enterprise customers, because if the Wi-Fi credentials get compromised, well, now they have to change the credentials for their entire network, which is obviously a huge concern. Any customer data that's stored on the device, product information, patient information, and things like that. So that's the basic things, the data. Denial of service. People are buying our devices and your applications really to increase the productivity of their workers. Right? If somebody can stop that by denial of service type attack, they've basically impacted they've defeated the whole purpose of having their productivity device. And then unauthorized access. So if they can use our mobile computers or your applications to get unauthorized access to their networks or other resources, well, now they could do other malicious things on the networks. When we talk about vulnerabilities and security, really the thing that people come to mind a lot about is rooting. So really rooting is a lot of consumer devices, a lot of hackers like to do that. They like to modify their OSs and things like that so they can put new features in it. In an enterprise environment, that's really not acceptable. Because really what that means is when you're rooting it, that means the application can get full access to the device. They can access any file on the device, they have full permissions on the device, they can just have keystrokes so they can get passwords and things like that. They can put malicious code on the device. So really our attempt here is, how do we prevent people from getting escalated privileges on the device so they can't do malicious type things on the device. It's kind of a vicious cycle, right? Attackers and researchers, find new vulnerabilities, new ways to compromise the device on a regular basis, a monthly basis. Google will provide updates and patches, and Zebra will follow, providing those updates on a regular basis. We patch it, and then the bad guys find other ways to do it, and it's just a never-ending cycle. Right? It's a reality of modern operating systems. It's not unique to Android. Every operating system, whether it's iOS or Windows, has similar type things. iOS also has monthly updates. Microsoft, they call it Patch Tuesdays, where they provide their monthly security updates. And it's an unfortunate reality of where we are, where people are trying to break into these systems. Obviously, the operating systems and the software are very, very complex. So there's millions and tens of millions of lines of code. So there's lots of vulnerability there. The fact that Android is open source actually has a big advantage there because there are millions of eyes looking at the code, finding vulnerabilities. Some of them have been there for years, and some of them are subtle things that people figure out, and then they're patched very regularly. At Zebra, we look at three main pillars from a security perspective. The first is prevention. Right? The main premise here, if a harmful application can't execute, it can't do any harm. pretty logical. So one thing is we prevent harmful applications from running, and we'll talk about many techniques that we use to prevent potentially harmful applications from running, which prevents any potential harm to our devices or the networks. The second is, well, if something did run, how do we detect it, right? So if somebody did something vulnerable on the device, can we detect it and take some countermeasure there? So that's our second pillar. And the third is keeping up really quickly with security vulnerabilities and security patches. And there's actually, right after lunch, Bruce Willens will do a session on what Joe mentioned yesterday is our Lifeguard, which is our security patching program, our monthly security patching program. We'll have a whole session on that. I'll touch on it briefly at the end. Google has put a huge investment in security from an Android perspective. They're doing many things there. Right? There's always been a perception that it's not secure, and it's really not really true at all. I think it's probably one of the most secure operating systems around, and you probably would say it's the most secure operating system. So they do things like verify apps. So verify apps, in essence, scans applications looking for potentially harmful applications. They do it not just on the device, so they'll scan applications on the device. They scan all the applications in the Play Store, and they scan applications on third-party websites, third-party Play Stores. So they look for .apks, application files, and they scan for patterns that are known in potentially harmful applications or vulnerabilities. And there's always been a perception that devices that use the Play Store or use a public Play Store have more vulnerability than people who don't, who use side-loading application. And actually, it turns out that's very far from true. Because the levels that Google does, and I have some statistics on the next slide, that they do in scanning applications so diligently, the percentage of potentially harmful applications that for devices that are using the Play Store are significantly low. And the quote from last year is 0.05% of devices that use the Play Store and a potentially harmful application. And when they talk about potentially harmful applications, that's not just applications that are doing malicious things, stealing data, things like that. It also includes things that are doing, sending ads and things like that that are unwanted or undesired characteristics, not necessarily malicious type things. So if you look at malicious things, it's probably even lower. So that's a very low statistic. For devices that were not using the Play Store, it's about 0.7%, 0.71%. So you can see there's a big difference there. And a lot of people over the years have always thought that, hey, I shouldn't use the Play Store, that'll make me safe. It actually turns out to be the other way around because they do such diligence in scanning those applications. The next thing they have, we'll talk about the architecture in a second, is what they call safety net. So they do a lot of runtime checking. They look for characteristics running from the device, what websites things are accessing. All of a sudden, you load a new application, and you're accessing websites in a different country that maybe you weren't doing before, or you're getting a lot more data that's being processed back and forth. So they can do a lot of different heuristics there, understanding trends. And since they're managing literally hundreds of millions of devices, they can actually start seeing trends and patterns and recognize when something doesn't look right. They also, and Andy talked about this a little bit in the last session, is a feature called device attestation. So as a developer, you can check to make sure the device that you're running on hasn't been compromised. So nobody's rooted that device, that it's basically how it left the factory. And how that works ultimately is, as an OEM Zebra, when we release one of our devices, we go through a pretty rigorous test through Google. They call it the compatibility test suite. And part of that testing, they keep a fingerprint of the device, basically various characteristics of the device. The OS was on there, the hashing of the OS and things like that. And at runtime, your application can make a call to confirm that with the Google Cloud and make sure nobody's compromised the device. So enterprise applications, things like Android Pay and things like that, use this to make sure that your application is running on a secure device and your application is not going to be compromised. Andy mentioned the number one user, this is probably not an enterprise application, is Pokemon Go. Kind of ironic, but thinking about it, if that's something that really needs to be secured, think about the data that your applications are using. Other things that Android is doing is they're mandating full disk encryption. So out of the box, starting with Android M, all the Zebra devices shipping with Android M have full disk encryption by default, and we actually store the keys. They're stored in a hardware trusted execution environment. So they're based in hardware, they're not in software, they're not in memory. So even if somebody compromised the device and probed the device, they couldn't get the disk encryption keys out of the device. our processes that we use actually have special instructions that accelerate the disk encryption, so you basically get the same performance with disk encryption as a non-encrypted disk. So there actually is no way to unencrypt the disk because it really wouldn't make sense to do that, and since it comes out of the factory, there's no overhead. In the past, when you had to encrypt the disk, you had to get the device, it took 15, 20 minutes to encrypt each disk, depending on how much data you had on it. Because now it comes that way, there's really no downside of doing it. The other thing that they insist on is verified boot. Basically what that means is every time the device boots up, it checks a hash of the operating system to make sure that nobody's compromised the OS, nobody's modified the OS, which could defeat any of the security features that are built in. And of course, their monthly security updates, which they do on a very regular basis, and Zebra gets the updates from Google and other vendors like Qualcomm, and we provide our monthly updates. A lot more details on an annual basis. Google provides a white paper. They call their Android Security Year in Review. Typically, security papers are not necessarily the most exciting read. It's actually a pretty good white paper. They have a lot of good information, a lot of good facts. It's not as boring as most security white papers might be. I apologize to the security practitioners in the audience, but it's a good thing they do on an annual basis. I'll let Andy comment a little more on this, but basically this is the overall architecture for what Google does, what they call their safety net, of ultimately how they secure not just the device. You see the device is just a little box on the bottom where they do things like sandboxing applications, verified boot, disk encryption as we talked about, but the whole infrastructure on the cloud to scan applications and look for different anomalies.
Great, so you can think of this as your roadmap for all the things that we're doing for security, particularly as you get outside and surrounding the device. So inside the device is on the lower left. We have, in that green box, all the things that we're doing at the very low levels. Each individual app is running in a separate process. That process of course it's a separate process, separate user. So if you're familiar with Windows, each app is typically running as the same user, and you've got access to the same memory space. In Android, that's not true. Each app is actually running as a completely separate Linux user ID. And then we've got the root of trust that happens through verified boot. We've got things like address space randomization that make it difficult to have attacks work that rely on Stack Overflow and other things. We're doing mandatory encryption ever since Marshmallow. The volume encryption is mandatory, and in Nougat we even have file level encryption. We have the Verify Apps capability that takes every app that's on your device, whether it's coming from Play or not, and we check based on static analysis, dynamic analysis, reputational analysis, to make sure that that application is not a potentially harmful app. We're using machine learning. We've got 20,000 processors that are doing this. If we haven't seen that app before, we will go and analyze that app and make sure that it is not anything that you need to worry about. We will warn you if it looks to be potentially harmful, and in extreme cases, we'll even block the app from running. This all happens through the cloud services that we've got on the back end that do all this analysis, that take all the things that we've got instrumented inside secure the SE Linux rule set. We can see when applications attempt to do things that are questionable, and even allows us to see actual infection rates from Android, and they're much lower than you might expect. And then we're able to use all this along with what happens in Play. We've blocked over 300,000 apps. Well, actually that was last year. We're probably well past 500,000 from being served through Play because they had outdated vulnerable libraries, or they had other practices that we were able to detect before the app was even published. And even if you're using the private app capabilities that Google Play has for serving up the apps that you're delivering only for internal use, you'll still get the benefit of this. And you'll be surprised, even some of the best developers that should know better will occasionally have somebody that will link an old library that's vulnerable, or do something that they shouldn't. And we pick these up before the apps even get published most times. Smart Lock, which allows you to take advantage of features that reduce the number of times that the user needs to be prompted for the lock screen. On body detection is an example, right? So you can require a more sophisticated lock screen credential, but the user ends up having to use it less often. It becomes less of a burden as a result. The safe browsing APIs, Chrome uses them, but anyone that builds a browser or an app can take advantage of this to ensure that the user isn't going to known bad APIs, right? All of this represents the most comprehensive security surround that any OS has ever had.
So, I mentioned some of the statistics, right? And it's kind of daunting, just the sheer volume, right? And this slide is probably a little dated since I borrowed it or stole it, right? But over 1 billion devices protected, right? 400 million devices scanned per day, right? And 6 billion apps checked per day, right? So just think of that sheer volume and the statistics they can get from that, and the trends that they can measure by looking at that sheer number of devices, right? So that's one of the areas that we leverage the success of the consumer ecosystem to help improve the security. Getting back to data, and obviously Google's a company that knows a little bit about data, is, if you remember my first slide that talked about the security headlines, right? Well, the reality of it isn't quite what the headlines had made it out to be. Stage fright, if you remember the headline, it said 95% of devices are vulnerable. When they talk about a vulnerability, so a security researcher basically says there's a theoretical possibility that somebody can compromise the device. It doesn't mean somebody's actually done it, or somebody's written an application to do what they call an exploit, to actually take advantage of it. It says in the lab, theoretically on paper, they've said it's possible to do this, like stage fright was a way to ultimately do a buffer overflow and inject some code to do some potentially harmful things. It turns out that there are no confirmed applications or exploits in the public that people have seen. So, while the headline was theoretically 95% could be vulnerable, it turned out nobody really was compromised. There were no confirmed applications that saw that. Now, my point here is not to say don't worry about it. Oh, it's no big deal. We don't have to worry about security. It's that the system is working, right? There's a lot of features in there, and we'll talk about more in the next slide. The whole layered approach to it. But if most of them are being detected, there's multiple layers of defense. So even while that buffer overflow could have occurred, there were other things, and we'll talk about in a second, particularly the address-based language layout randomization that basically prevented anybody from successfully able to take advantage of that exploit. Even the worst case, the master key, you look at the billions of devices that they have, 1,200 applications that were potentially had an exploit is relatively low in the scheme of things. Probably significantly lower than Windows or other OSs. The way I like to look at security, what the security people call defense in depth. And that's really just a fancy way to say it's a layered approach to security. Simple way to look at it is if you have a lock on the front door of your house, somebody gets the key, they can get into your house. But if you have multiple locks and a chain and an alarm system and a big dog, the more layers you put to defense, the harder it is for somebody to get in. Same type of thing with somebody attacking, one of your Android devices, multiple layers of defense. So, look at it from the top going down, and again, the basic thing is how do we prevent potentially harmful code from executing? First thing is prevent unauthorized users on the device. Pretty simple, they can't get on the device. They can't actually do anything sinister on the device, so that's with passwords and multi-user passwords and things like that. Next one is, well, somehow they got on the device. How do we prevent them from installing unauthorized applications? So we basically can control people copying files on or off the device. You can't get the APK on the device, you can't get the code on the device, you can't install it. we have our enterprise home screen, which is basically, a replacement for the standard Android home screen, which is configurable by an administrator of what applications are allowed. So that potentially harmful application, if somehow it got on the device, nobody could actually install it because the icon wouldn't be exposed to do that. Well, let's say somehow they get through it, they get on the device, somehow they got an app installed on the device. Well, they can't launch it. They can't launch it because we prevent it from being launched. Right? Again, our enterprise home screen and our MX features basically can whitelist and blacklist applications. What that really means is we can control through an EMEA interface which applications are allowed to run. So presumably you wouldn't allow that malicious application to run on your device. You'd allow the Google apps that you want and your line of business type applications. So it looks up at that list, the white list and the black list, and says these applications are allowed to run or not, or allowed to launch or not, right? The next level is if somehow it got launched, we actually can stop it from actually executing. So you got it installed, you launched it, so you got past the first layer, first two layers. But once it actually starts to run, now we can actually check and say, hey, this is not allowed to run, stop it from running. And related to that is the application signing process. As you may know, all Android applications have to be digitally signed with the publisher. It won't let you update an application with a different version that doesn't have the same signature, so nobody can spoof your application and say, hey, this application is allowed to run, myapp.apk or whatever it is, because it has to have the same signature, and presumably you wouldn't give up your private key to let people do that. So those are the first four layers. Well, let's say somehow somebody got through the first four layers and they got an application to execute. Well, now the next layer is, well, how do you prevent an application that's running from escalating privileges, from doing bad things? It's running, but there's lots of mechanisms for stopping it from doing bad things. So some of the things that we do unique, and I should have mentioned the zebra logo there, are the things that we're doing unique, and the other ones are standard Android. Over time, when I first did this slide a couple of years ago, more and more things were zebra unique, right? Over time, more of these are becoming part of the standard operating system. So we'll encrypt the Wi-Fi keys. So somebody got on the device, they couldn't get the Wi-Fi keys. Remember from one of my first slides, that's one of the things that enterprise customers are most concerned about. Right? The disk is encrypted, so even other files, patient data, things like that, couldn't be taken off of the device. Won't go through all of them. System permissions basically allow applications have to advertise what they're using, what features they're using on the device. System level ones, privileged things, can only be accessed by applications that are signed by the OEM, right? And Zebra is very diligent at making sure we don't sign applications or untrusted applications with system privilege, because if we do that, they have full access to the device. They can do system level things. In some cases, that's not always the case, but we're very diligent because we're going after enterprise scenarios. Hardware-backed key store. So all the keys are stored. I mentioned one of those slides, what they call a trusted execution environment. ARM calls it trust zone. Basically, it's a secure piece of hardware, part of the processor that can't be accessed normally, and that's where all the keys and private information or secure information is stored. So when you've got a certificate or any key, it's actually stored in that hardware trust zone or that hardware key. Address space layout randomization, which is a mouthful, but really what that, and position independent executable, whenever something loads into memory, they load an application into memory, right? Where it loads in memory is randomized. Very common technique for hackers is, inject code with a buffer overflow or things like that, and then they can, by modifying your return address, they can actually cause other code to execute. Well, if every time the application loads, it loads someplace different in memory, that becomes significantly harder to do, because now you don't know where things are in memory. You can't just run it once, figure out where things are, do a dump of the memory, figure out where things are, and where you have to modify the code, because every time you run it, it's going to be different. Now, I'll never say it's impossible. I'll say it's significantly harder to do that. And I believe that's one of the reasons why StageRight was so difficult. While it was theoretically possible, right, in practice, because of things like that, it was not practical for people to actually take an exploit there. Things like, the no execute bit, which is a hardware feature that says, this section of memory is code, is data, not code, so don't execute it. And then, being able to put modifiers or or features in the stack to make sure people aren't modifying the stack for buffer overflows and things like that. So there's a myriad of things that are put in to prevent people from escalating privilege, from doing things they're not allowed to do. If you think about malicious application, wants to do things that are escalated privileges, or things that mostly system applications or operating systems would want to do. If they're operating within their own sandbox, they can harm themselves, but not the rest of the system. Right? And then the final step is, well, let's say people got through all the other 5 layers, they got on the device, they somehow, installed an application, launched it, executed it, right? Did something malicious, right? Well, now we can detect it. One of the things that we've done is we have an active, in our RMX feature, we have an active threat detection. So we can actually detect things like somebody rooting the device, and then take a programmable countermeasure, like for example, locking the device or erasing all the data on the device, because we detected that can happen. Google, we mentioned that there are safety net and verify apps, right? So they can actually check, hey, this app, it has a pattern that indicates it has a vulnerability, stop it from running, uninstall it from the device, let the administrator know that something bad has happened, right? And then the attestation API that we talked about is a way for you to say, hey, your application could check, has this device been compromised? This device is compromised, don't do anything secure, right? Unload your apps, delete your data, whatever that you want to take advantage of. So, again, I never say that it's impossible, right? I just say, the more layers you have, the harder and harder it is for somebody to compromise the device. And that's really the best principles in security, is to have multiple layers of defense, so it's harder for somebody to get on the device and do something dangerous on your device. Some of the things that we can lock down, all the interfaces. So if you're not using the USB port, for example, or the ADB, which is the Android debug interface, right? We can disable that, so you can't actually use that to get data on or off the device. If you're not using Bluetooth, we can shut that off. Wi-Fi, NFC, any ways to get data on or off the device, SD cards, things like that. In enterprise, if you're not using SD card, right, disable it, so people can't use that as a vector to get malicious application on the device or steal data off the device. Turning off the various sensors, right, whether it's the GPS or the camera, we can do that through our EMEA interfaces, our MX interfaces. Being able to disable, somebody taking a screenshot, or people accessing user settings. So for example, they can go in and reconfigure Wi-Fi to go on an open network, right? They can get on an insecure network that doesn't require a password. Maybe it's redirected to other sites, and then they have potential vulnerabilities that way. By locking that down, they're only going to the websites that you've configured or the EMEA has configured. So these are many of the things that we do, in our MX Mobility DNA suite to allow people more control of locking down the devices. And the basic principle here is really only expose the functionality that's required. If you're not using SD card, no reason to leave it on. You can disable it. In a consumer device, you don't know what pip somebody's going to do next, right? So it's really more of a generic and open system. In an enterprise system, it's a fairly controlled environment, so we can actually tailor the system to what the needs of the user to get the maximum level of security. I mentioned our active threat detection, right? So RMX feature basically can scan for these types of threats. It runs autonomously, it doesn't need to be connected to the cloud or any network setting. Once it's configured, it'll run in the background looking for threats, like somebody uninstalling an EMM, somebody rooting the device, and then you can configure what you want to do, right? This sample matrix kind of shows potential things that you might want to do. So for example, if your device is rooted, maybe you want to factory reset, which brings it back to the state that comes out of the factory, so there's no data on the device. So maybe they can compromise the device, but they're not compromising any of your data, your application on the device. They can't get on your network. Or you can lock the device, or you can send a notification, notice to a user, or things like that. So, this is a pretty powerful feature. This is kind of the last level of defense. It says somebody's got on your device, they've done something bad. How do we detect this happens, and what do you want to happen? What do you want the countermeasure to be? Right? Automatically, without any user interaction. And then the final thing is, as I mentioned, is Lifeguard. So Lifeguard, as Joe mentioned yesterday during the keynote, is the program we announced a couple months ago, which is to basically do regular security updates for a long period of time. Right? We realize enterprise customers, the life cycle is much longer than consumer life cycles, so we've expanded Google typically goes 2 to 3 years for consumer phones, which is a fairly long time for a consumer cycle, but from our cycle, it's much longer. So we do it for a much longer period of time. And we also have an OS transition period, because we know people won't switch OSs, right away. So we'll have to support the current OS and one version back for a period of time we call the OS transition period. A lot more details, Bruce Williams will be talking about this. I think it's in the same room right after lunch. We'll do a whole session on Lifeguard and security aspects there. Mentioned full disk encryption before. It's mandatory for new devices. It's encrypted at the factory, technically on the first boot, which is booted up at the factory. It encrypts based on a random key that's stored in the trusted execution environment, in the trusted execution zone. All our new devices have hardware accelerated encryption for performance. Can't be unencrypted, really no reason why you'd want to do that. Ultimately what it does is the whole image, it creates a hash of every block, and it stores the hash of the hashes, so to speak, is stored securely and compared at every boot to make sure nobody's compromised it. So again, if somebody modified the OS, they could change some of the security features, so this is really an important feature here to make sure nobody's modified the OS. Verified boot is somebody modifying the OS, and this is really protects against malicious OS changes, and this is where it's the hash of each block of data, and it's traced to a known good hash that the first time it was booted. When we build the image, we create a hash of the entire OS image. Every boot, we check that hash to make sure that it hasn't been compromised. And this is all Marshmallow devices and above have this by default to give you confidence that nobody's modifying your operating system. So, in summary, Android is a very secure operating system, right? Best practices for security perspective is whitelist and blacklist for the required application set. So only allow applications that are required in your environment. If somebody's not using a browser or not using a particular application, don't expose that to a user. Disable unneeded interfaces, so particularly ADB and USB interfaces and SD cards, things where people have potential to put data on or off the devices. Control access to settings, so the user can't go in and play with the settings and compromise the device. And plan for regular security updates. I know we mentioned that, hey, there haven't been, the reality was the malicious or the exploits haven't been significant despite the headlines, but we really need to have the diligence there. Don't assume that there will be some compromise. We should put lots of diligence there. I think, if we go back to the WannaCry, where Microsoft had the patch in March, but in I guess May or June time when it actually affected people, many people still didn't have their Windows devices patched. So I don't want to see people kind of doing the same thing here. Cool. So we have time for a few questions.
Question about, you mentioned about the list privilege.
Yes.
So is it specific to the Dynamics, or are there some list privilege that are also provided as part of Android Enterprise standard?
Yeah, it's a combination. Some of the ones, the ones that I had with the little zebra icon were things that Zebra had put specifically in. Were you talking about this one, or?
Yeah,
this one?
no,
Okay.
yeah, this one,
Yeah.
Well, interesting to see that as part of AMX, you are providing some capability to lock some of the functionality. But as part of the standard Android device, is there some?
Yes, yeah, and Android Enterprise, that Andy spoke about in the last session, has added a lot of these types of features, right? Not all of them, but they've added a lot of the features where you can basically, disable certain functionality for that kind of
so
device.
that's on top with AMX, you can do more.
Yes. And over time, as Android Enterprise is adding features, we'll leverage the Android Enterprise features and only focus on the ones that are unique, like the ones that they haven't done yet. And some of them are unique to our hardware.
Okay.
Yes.
How do you handle system updates with set the hash to verify that it hasn't been altered?
Yeah. So when we do a build, right, we digitally sign the image so to ensure that it's coming from us. right? And there's a hash in there, so when you do the update, it'll basically, the verified boot would still work, right? One of the things, you can't do a file-by-file update anymore because it does a block-by-block hash. So our updates are actually block updates. And what we're moving to is a differential update, which will basically be in effect a binary difference from the previous version to the new version to keep the size small, but also make sure it's secure, because it'll actually update the hash table. But it can only come from an update that's signed with the signature that we have that's stored in the trust zone or the key environment. So the key is on the device from the factory, can't be modified, and the fact that we have the private key that's not on the device, that we can sign the image and make sure that it matches and the update is done. Yes?
Going back to the example about using like an outdated library in an enterprise application, what would happen in that scenario if the app failed that verified app process and then your enterprise application was shut down by Google as part of that app security net scanning? Is there any way to whitelist your enterprise application from that scan process in any way?
Well, remember that most of that is applied when you publish an app in play, right? Even a private app. So the rejection process is specific to the publication process. If you're sideloading the app, obviously you don't get that benefit, but we don't take every app that has a vulnerable library and block it from running. That's when we talk about potentially harmful applications, we're talking about applications that are actually doing things that are obviously dangerous for end users, right? You don't have to worry about getting whitelisted just because you have a vulnerable library.
Any other questions? Yes?
There's been some security breaches released by WikiLeaks lately. Are you also addressing those, like things that government agencies exploit or use, like NSA and all those things? Are you considering this?
Do you have a specific example?
I'm just saying that there's been some information released which was talking about government agencies.
Yeah, if you read those documents, what you find is that they spend a lot of time complaining about how most of the exploits that they describe in those documents aren't working on newer versions of Android. I think you'll find that there's very little in those documents that points to exploits that still work.
Yeah. And then, for the most part, the governments have that, done, responsible disclosures, which basically means that they disclose to the OS vendors before making it publicly available, right? So that as Andy says, they can be patched before anybody knows about it.
Well, this is, I think you're specifically referring to the WikiLeaks.
Yes.
Yeah. I don't know that the intelligence services generally practice responsible disclosure. I think.
They meant like the WannaCry, which was the NSA one, right? But
Yeah.
which was actually that's what Microsoft knew about it beforehand.
There was
Yeah.
also some information about it once they attack your device. They're able to go around the boot of the device and go around your OS update. So their code will still resist on the device even after you try to factory reboot it. So does this work?
Yeah, so those kinds of techniques used to work on older devices. Right now, the process that we've got, we're not aware of any state actors that are successfully able to bypass it, but I mean, at this point, the data that's in that, we've gone through in detail the data that's in that dump, and unfortunately, a lot of it's pretty dated, so we don't have anything more modern to be able to compare, but what we do know is that the exploits that are discussed don't work anymore.
Okay, so the way is to be updated with the new systems.
Yeah.
The new system we have, but the track is nice.
Yeah, And what you're talking about, like a persistent threat, which means, you know, it comes back, so to speak. That's the intention of verified boot is to detect that somebody's modified the OS, right?
Yeah.
Okay, yeah. So-
Typically, it involves writing to the factory reset partition, and that's extremely difficult now.
So again, nothing's impossible, but it, you know, over time, it becomes harder and harder to do these types
So
of things.
making it harder for the government to.
Yes.
Yeah, that's why I think for us, the most interesting thing was just hearing how loudly those groups that are responsible for attacking were complaining about all the changes that have been made to both OSs, frankly, in the last few years. Yeah. And I go to security conferences regularly that include contractors that have to do things for governments, and you know, I hear lots of complaints about why won't you let me change SE Linux rules for my government customer that wants to do very specific things that, you know, no enterprise customer would want to do. So it's, you know, it's a cat and mouse game. It's never going to be over, but certainly we're at a stage now where the bar is significantly higher than most of these state actors would like.
And part of it is, you know, the level of effort and the money you have to put in to do the exploit. Any other questions? Well, thank you very much.